Hello and Assalamu alaikum. Welcome to the channel, The.multitutor. Okay, today we will discuss exact differential equations. We have a dy over dx is equal to a function. Remember, this would identically feel like the homogeneous function or even non-homogeneous function, but there we don't have a linear factors. This can be written as in this particular form, and we will call an equation as exact if it is satisfy this particular condition. What does it mean is whatever written with dx, we have to derivate it with respect to y, mean the partial derivative, and then anything with dy we have to differentiate with respect to x. If the both answers are equal, we will call it a differential equation, which is exact or exact differential equation. Okay, hopes you get the point. The next point is to solve it. Remember, exact differentials has been solved in a particular manner, which we will discuss in this particular video. So now this is written as the same format which we will discuss, and this is, remember, this should have been equal to 0 for initial conditions. Now anything which is written with dx, we represent it with m. So 3x square y plus 2, and anything with dy we write it as n. Okay, now what we need to do is we make a partial derivative of m with respect to y, opposite of this. So I hope everyone knows how to take the partial derivatives. It is the derivative with respect to a one variable where we will consider other variables as constant. So 3x squared remains there. The derivative of y is 1 plus 2. It is constant. Whether we other point of view of x or y, it is just a constant, so we just ignore it. So 3x squared is an answer of curly of m by curly of y. Now with n, we take a derivative with respect to x. So we have 3x squared. Remember, this is constant for reference of x, so we will ignore it as well. Now consider, now just check out that curly of n over x is equal to curly of m over curly of y. So yes, we will get a go ahead that it is exact. Now what we need to do is we can separately integrate this and this. Okay, so make an integration. We have 3 x square y plus 2 dx. Separately integrate this and separately integrate the other element, that is x cube plus y dy. Remember, this is an integration with respect to x, so we just integrate. That's 3 x power 2 plus 1 3, y remains there, so by 3 plus 2x. So we will have x cube y plus 2x. Remember, we have to place a constant, but there instead of constant, what I need to play is a function of only y. You have to place in dx form, you have to place plus hy. Don't forget it. So we have hy. Okay, now integration of this particular one. So x cube will remains there because we are now integrating with respect to y. So y appears plus y square by 2. Now anybody's guess? Yes, we need to place a constant that is having x. So it means we ultimately end up with x cube y plus y square over 2 plus gx. I hope everybody gets the point. Now we just need to write the answer or the solution of the equation. Just observe, this term is same. Write the same terms, x cube y, then write x, that's 2x plus y square by 2 and write it equal to c. That's it. That's the solution of it. And if you want to consider that gx here is actually 2x and hy here is actually y square by 2. I hope everybody gets the point. Now we will try to solve some initial value problem or some advanced level problem in this particular case. Now, if you are new to this channel, kindly like, subscribe and share. Thanks. Now, we will discuss some initial value problem. Now, firstly, the question will be solved exactly the same way like we did before. Now, we firstly check out whether it's an exact form or not. Now, we have to make it in a line. So, we have m equals 2y sin x cos x plus y square sin x. Now, makes a curly of m with respect to curly of y. So, 2 remains there, derivative y 1 sin x cos x plus 2y sin x. So, it means we have 2 sin x cos x plus 2y sin x. This is m. Now, we will consider n. Okay, sometime examiner will deceive you. We makes an habit that there firstly is dx and then dy. Sometimes they have given dy first. So, be careful while reading a question there. The one with the y is actually n. So, curly of n upon curly of x equals, okay, derivative of 2 sine square, 2 comes forward with the power rule, then the derivative of sin x is cos x, then minus 2y will remains there. What's the derivative of cos x? That's minus sin x. So that's end up on 2 sin x cos x plus 2y sin x. Now just consider the both answers. They are same. It means curly of m of curly of y, curly of n, curly of x. Yes, it's exact. Now we will repeat the same process. Mean we have to take an integral of dx separately and dy separately. So firstly the integral I'm just taking with just right there the dx1. So we have 2y sin x cos x, and we have plus y square sin x dx. Okay, I have told you before in the previous lectures, if your integration is up to the mark, you just need to learn some initial steps of differential equation, and then differential equation is just like a child's play. So integral of dx, okay, 2 is constant, 2 remains there, y is constant, remains there. Can you tell me, we have a notation where there is a function and there is a function of derivative of function? Yes, we have. Sin x derivative is cos x, so we just can simply increase the power of sin x and that's divided by 2. then plus y square as it is. Okay, what's the integration of sine x? Yes, right, that's cos x. And what we need to write is, we need to write plus hy. So now this crossed, so we have y sine square x minus y square cos x plus hy. Now takes the integration of other half, sine square x minus 2y cos x. Okay, hopes everybody gets the point what we are doing till now. Okay, this is only x, so dy we are doing integration with respect to y, so y sine square x. If it doesn't appear in an statement, then it comes into integration. Hope you have the knowledge about that. So minus 2, what about y? We have y square by 2, then we have cos x, and what we need to do is we need to place plus gx. Okay, this 2 will be crossed, so we are left with y square sine x minus, no sorry, it's not, the first one is not the square, square is on this, so now we have y square cos x plus gx. Okay, if you observe it with the red one, it is exactly the same. I mean, we need to write the answer, both terms are same, and there is no unique value which appears in one, so it means we have hy equals 0 and we have gx equals 0, so we need to write equals c. Now next part is to find the value of c, because we are solving an initial value problem. So for this we will go up, and what condition we have? We have equals 3. It means whenever we plug in a value of x0, we have y equals 3. So just we are going to place it there. So 3 sine square 0 minus 3 square cos 0 equals c. Okay, what we have, so that should be 3, so that's turn out to be 0, because sine 0 0 minus 9 cos 1 c. So we have minus 9 equals c. So the above equation we can write it as y equals sine square x minus y square cos x equals 9, or even you can write it as y square cos x minus y sine square x equals 9. What I do is I just simply multiply the whole equation with minus. There is no need to do it. You can write it this answer. It's perfectly fine. But sometimes the answers in books are different. What they do like this. So don't be worried. If you follow the correct steps, your answer would be right. Hope so. You get the point. With the next video, we will meet again. Up till then, Allah Hafiz.